We are recording, be careful. So let's do a recap on trigonometry. So you tell me, this trigonometry malarkey is to do with what shape in particular? More specific.
Right angle triangle.
A right angle triangle. Okay? So remember, what we're doing is only, at the moment, to do with right angle triangles. Okay? So we've got a right angle triangle. It has a 90 degree. And if this is an angle, we can label the three sides. So I've used this sine theta. So this side would be called the hypotenuse. Okay. What's this side called?
The opposite.
It's the opposite side. And this side would be the adjacent side.
I don't know how to say.
Adjacent, next to. So the adjacent is next to the angle. If I move the angle to consider this one instead, obviously the opposite and the adjacent side change. They switch. The hypotenuse, how would you remember the hypotenuse? Yeah.
The one opposite to the right angle.
The one opposite to the right angle, and it's the longest side always. Does every triangle have a hypotenuse?
No.
Which ones don't?
Yes, but sometimes we can't tell.
Equilateral triangles.
Which triangles have hypotenuses?
How?
Yeah, which have
Right angle triangles.
right angle triangles have a hypotenuse. If it's not a right angle triangle, it doesn't have a hypotenuse.
Every does.
Oh, sorry, I'm wrong.
What?
If it's a right angle triangle, it has a hypotenuse. If it's not a right angle triangle, it doesn't have a hypotenuse. Yeah?
Can't you, but if you draw like a triangle that is, the angle is too small to be a right angle, but you have one really short one, one longer one, and then another one, would that be the hypotenuse? Because isn't it the longest side?
Well, it is the longest side of a right angle triangle, but Nico's definition was opposite the right angle, which is good. So how can you have an opposite the right angle if you don't have a right angle?
Can't the opposite of the adjacent be longer than the hypotenuse?
No. That's not possible.
Can't you just stretch it out?
Yeah, but if I stretch the adjacent side out to here, I make the hypotenuse longer. I can't just extend that line and leave the hypotenuse there. It doesn't work. The hypotenuse is for a right angle triangle, so don't write this is the hypotenuse if it's not a right angle triangle.
But the is it true that Pythagoras said that the quadratic hypotenuse equals opposite in squared plus adjacent?
Well, that's a different thing, isn't it? Pythagoras' theorem, which we've already done, right? The hypotenuse always had letter what?
A.
For us, we study hypotenuse had it. I think you said it. I mean, C. Sorry, it came from it. So that was a C, and these two were A and B, and it didn't matter which way round. And we knew that A squared plus B squared equals C squared. Okay, so the two shorter sides squared add up, make the longer side squared. But that is Pythagoras' theorem, and it doesn't involve an angle. So I can use Pythagoras' theorem to find sides only, right? And it doesn't involve angles. If I have an angle and I'm trying to find angles, or I'm trying to find side with an angle, I have to use trigonometry. So trigonometry, which is the route we're going down, we use these three sides and we have certain ratios, which you should all know now. So we have the number, sine of whatever angle it is found by doing what?
Opposite over
The opposite side divided by the hypotenuse will give you a number, and that number is the sine of the angle, which we can use to find the angle. The cosine of the angle is
adjacent over hypotenuse.
The adjacent side divided by the hypotenuse. And finally,
Hypotenuse over adjacent. Oh no. Opposite over adjacent.
the tangent of the angle to start is what? Go on, you.
Opposite over adjacent.
The opposite over the adjacent. Okay, now you looked at a quick way of remembering, so that was so, ka, toa, just to help you remember. Okay. Jessica's grinning. I always wonder what that means. There you go. Some old hags came and had tea one afternoon. Right, so you have already learnt, so I'm not going through everything, you've already learnt how to use these ratios to find a missing side, or you've used it to find the angle, right? So for instance, let's just check, if sine of the angle is opposite over hypotenuse, what is the angle on its own? How would you do it? Because if I do opposite over hypotenuse, I get sine of the angle. So you have a way using your calculator of finding what just the angle actually is.
Use the
Bit more than that.
Use the sine minus 1.
Yeah, we have to do the
Inversion.
inverse, yeah. The inverse sine, so we do sine to the minus 1 of the opposite over the hypotenuse, and that will tell us the angle itself. Okay? So we only really need to do this sine to minus 1 if I want to know the angle. If I'm given the angle and I want to know a side, I can rearrange it. Okay? Now you should all know how to do all this now. This is a recap. I shouldn't have to go through any of those. Alright? If you do, you've got some work to do tonight. Alright? You all remember on your calculators how to make the inverse sine, inverse cosine button work? Because there won't be any use of phones and things. If you bring a calculator without those buttons, you won't be able to do it. Okay, you should all have your calculator.
Can you remind how to do it, please?
The inverse sine, well, you've got a second function sine probably.
Click the second tab, and then whichever
So-
one you want to inverse.
So normally you've got sine and you've got the inverse sine above it, and you have to use the second function. Now just remember, some of you will have to put the number in first and then press sine. Some of you will have to press the sine first, then put the number in. Okay? You have to, this is why I would always say you have to have your calculator, and you should bring it to every lesson to practice using your calculator, so you know what things your calculator does and the way it uses things, right? It causes problems when you walk into a test and you just borrow someone else's calculator, because they don't all work the same. Okay, so you need to get into the habit of having yours. Right, let's have a quick look then. You wanted to look at exercise 10D on page 187. Okay, and it is solving problems using trigonometry. Now, this is what normally happens. These are the type of questions you're going to get in your assessment. Okay, not simple, here's a triangle, find the side. You're going to have to identify where the triangle is in this problem. Okay, so for instance, let's have a look at question 1. All right, and Simon places a ladder against a wall.
What is a ladder?
A ladder is something you climb up to get higher. You know, you kind of with rungs and you step up. So a ladder, for instance. So if we say a wall, now we actually do make some assumptions here. And an assumption is something that you can make which is probably true, but quite often in maths you shouldn't make assumptions, but sometimes we have to. What assumption have I made if I draw this diagram? if this is the wall and this is the floor, what assumption have I made?
That the wall and the floor are at 90 degrees.
Exactly. We've assumed that the floor and the wall are at 90 degrees, which actually you know and quite often is not the case. Right here, if I put a ladder in this classroom, it would be. But so what we have then is if I put the ladder against the wall, that's the ladder. Right? So it rests on the floor, leans against the wall. All right? You can see that it creates a right angle triangle. Now it tells us that the ladder against the wall makes an angle of 76 degrees with the ground. So this is if the ground is there, where's the angle 76 degrees? Here, here, here. 1, 2, 3. 3. Okay. 76 degrees is there. Now you'll notice I'm drawing my diagram, I'm labelling my diagram to make sure I have it all here. I will expect you to do this in your test as well. It says when the foot of the ladder is 1.8, the foot is like your feet, it's the bottom of the ladder, it's 1.8 metres from the wall. Okay, so we should put that in. And the ladder, okay, so, oh, we don't know actually. So, yeah. So 1.8, we don't know how long the ladder is, it doesn't say. But we want to know how high up the wall it goes. So we need to know this distance here. So we'll call that x. Okay. Right. Now we don't know how long the ladder is, but we know it touches the wall and it touches the floor. That's where the thing comes in. I've told you how to set a problem like this out. What do I start with? What am I going to expect to see? So we write down the SOHCAHTOA. We're expecting to use SOHCAHTOA because it's a right angle triangle. We then write out theta, opposite, adjacent, hypotenuse. Get into the habit of writing these out, looking at people in particular about writing out their solutions properly. And then we identify which ones. This is just to make sure we don't get it wrong. So, do we know the angle?
No. Yes.
76 degrees. Okay. Do I know the opposite side? Do I want to know the opposite side?
Yes.
Right, so that's x. Do I know the adjacent side?
Yes.
1.8 meters. Do I know the hypotenuse?
No.
Do I want to know the hypotenuse?
No.
No, so I'm going to cross that out. Okay, and therefore I can cross anything out up here which has a h in it, and that leaves me with only one. I shouldn't cross. So we know that tan of theta is opposite over adjacent. So I'm going to write that. Then I'm going to put my numbers in that I know. You might think this sounds all quite long-winded, but it's going to get us the right answer in the end. So tan of 76 equals x over 1.8. So I've got to do something with that to solve for x. Go on.
Do you multiply both sides by 1.8?
Good. Multiply both sides by 1.8. I'm very glad you said that and not move the 1.8. I'm glad you get it. So that leaves me with 1.8 times the tan of 76 equals x. So now, you just have to do it on your calculator. Okay, so there's a good point. Normally we would do, let's say, 3 significant figures. An angle, though, would be to 1 decimal place. So let's do the side, because that's what we're looking for, x, to 3 significant figures. What do you reckon it is?
7.219.
4 significant figures you've got.
Yeah. You need 3. Significant figures. It's numbers after the point.
No, not necessarily.
Just
No,
numbers in general.
just the first 3 numbers.
7, 21, 22.
7.22. You think? What does it, does everyone agree with that? Yeah. Sounds all right then. Now the thing is, what I would just say is let's check. Does that look reasonable? Is a ladder going to reach 7.22 meters up a wall?
Yes.
Potentially. It's a long way up. I know it could be a very long ladder, but it makes some sense. You should always check that the numbers make sense. If a number doesn't make sense, let's say we got an answer of 0.08 meters, 80 centimeters up the wall. Are you going to write that answer down? No. What do you think might have gone wrong? You've checked all your working, you've got all of that right, you can't find any mistake. How's it gone wrong if you've got a number that just doesn't work? Go on again.
Maybe on your calculator at the top it says like instead of DG it might say something else.
Yeah, so if you haven't got your calculator set to degrees mode, it might be in radians mode. Remember we talked about that. That will give you an answer that's completely wrong. So if a number doesn't look right, check that you're in degrees mode and check that you can do that with your calculator.
Yeah.
Okay. Yeah? Check you can do that. Okay? So there's our answer. Right. Let's have a look. Now you wanted to look at question 7. Is that the one you couldn't figure out where the triangle was, Carmen? Yeah? Let's have a look then, just quickly, before lunchtime. So, question 7, we have a triangle. What kind of triangle?
I saw.
Isosceles.
Yeah.
Isosceles, okay. We have an isosceles triangle and we know that AB equals AC. So we know that AB is 8 centimetres, okay? And AC is also therefore 8 centimetres because it's an isosceles triangle. We know this is the height of the triangle. Now if I split an isosceles triangle down the middle, I create 2 right angle triangles. Okay? So it says, what is the perpendicular height? Now perpendicular means at right angles. We've got that. Right? It tells us that the angle ABC, so ABC is 64 degrees. Alright? We've got to find H. So, I'm just going to highlight, you wanted to know where the triangle was. Well, highlighting that there. There's your triangle.
Isn't H the hypotenuse, 8 centimeters?
No, H is the height, the perpendicular height of this triangle. What, by splitting it into 2 right angle triangles, okay? So if I get rid of that. There is the triangle, but obviously it's written away. Okay, by splitting it, I've now got 2 right angle triangles. So again, let's do SOHCAHTOA. Let's do theta, opposite, adjacent, hypotenuse. What is theta? 64 degrees. Opposite?
X.
Well, in this case, H.
Yeah.
Adjacent?
We don't need it.
Don't need it. Hypotenuse? 8. So SOHCAHTOA, we need to get rid of anything with an A in it. So I'm left with sine theta equals opposite over hypotenuse. So that would be sine 64 equals H over 8. And Ollie, H equals?
H equals 7.2 centimeters.
But how do I do it? What do I do with this?
8 sin 64.
So 8 times the sine of 64 equals h. So you've done that on your calculator already and got
7.2 centimeters.
7 point. If it's 3 significant figures, if I ask? 7.19, is it? And just finally, I didn't do it in the other one either, but I'm just going to check. Let's say there's an extra mark for units. You lose it if you don't write what there.
Centimeters.
Centimetres. It says in the question 8 centimetres there. Look, I wrote it there. Right. So if you don't, if there are units in the question, you should put units in the answer. Okay. So if it says centimetres in the question, it will want centimetres in the answer. Okay. Sorted? What about question 4? Were you all okay with bearings? Yeah?
It was 10.
Well, the thing about bearings, what's important about bearings, the angle is always measured clockwise from north. Okay? It's always measured clockwise from north. So it's quite nice on that question. I think they've given you north. So you start at north and you go clockwise. So be careful that you get the right angle with bearings. And just for question 5, there is that angle 42 degrees is called an angle of what? Anyone remember? Begins with E. And it's like, what do you do? What does a magician do? Almost, but not quite.
Levitate.
Oh, levitate. Don't laugh at him. You haven't come up with anything better. It's close. Begins with E though.
Elevation.
Elevation. It's an angle of elevation.
That's exactly what I wanted to say.
Oh, it's what you wanted to say. Oh,
I
how dare I ignore what you wanted to say?
I
Say it next time. Elevator, yeah. When you go up, it's an angle of elevation, and when it goes down, it's an angle of
9.
what teachers get at the end of a year when they see all your maths results.
Headaches.
Depression.
Disappointment. No, it's not an angle of disappointment. Depression, yeah. Alright, so you've got elevation. Right, so remember those bits of vocabulary because you may well need them.